17, 18, and 22. Today we're going to talk about number sequences, indices, and complex curves. In detail, today we're going to talk about number sequences, which consists of patterns in number sequences, finding the nth term, and further sequences. In indices, we're going to talk about key points of an indices, multiplying and dividing indices, and fractional indices. And the last topic we're going to talk about is complex curve. So first one, number sequences. Firstly, you need to know some keywords. So a number sequence is an ordered set of numbers with a rule to find the number in that sequence, which is called term. And the term that link from one to another straightforward is called consecutive terms. So you can see at the two examples here. So the key to number sequences is to find the rule of it. For example, you can see between the consecutive term here. In example 1, you have to add 7 to the previous term each time. So it's called the term-to-term rule is add 7. On the second example, you can see that you have to multiply the previous term by 2 each time. So the term-to-term rule is multiplying by 2. So next one. You can't always see all the terms of a sequence, so that's why you need to use the Nth Term Formula to find the exact term that you want. It is always in the form of a(n plus b, where a is the difference between each term and the next term, or we call it consecutive term, and b is the difference between the first term and a, which is the difference between consecutive terms that we just talked about. Now, for example, I have a number sequence here. It is 2, 5, 8, 11, 14. So first, you need to find a, which is the difference between the consecutive terms here. We see that they all have a difference of 3. So a equals 3. Then you need to find b, which is the difference between the first term and a. So you take the first term, which is 2, minus 3, which is the difference we just found out. So we have minus 1. So the nth term is 3n minus 1. But sometimes the difference between the consecutive terms is not always the same. So that's why you have quadratic and cubic sequences. So I have the sequence 5, 8, 13, 20, 29. You can see the difference between the terms are 5, 3, 5, 7, 9. So it is not the same anymore. So it is not a linear sequence. So now you need to compare the sequence with square numbers or cubic numbers. But firstly, you're going to compare it with the square number sequence. You can see here that each term is 4 more than a square number. So the nth term is n squared plus 4. So it is the same to cubic numbers. So why do we need to compare it? Oh, because the point here is to find the same rule. You need to find the similarities between the given sequence and the square number sequence or the cubic number sequence. If there are some similarities or that can apply to all of the terms in that sequence.
So more about sequences, we're going to talk about exponential sequence. So exponential sequences are sequences that have the variable as the power, and it could be written in the form of ab to the power of x. So here we have an example. The exponential sequences, if you plot it into the graph, it will start as 0 and go to positive infinity. And an example of how to write the exponential sequence, here you could see the function of the graph is fx is equal to 2 to the power of x. So what the IGCSE would want you to do is they would want you to work out the rule of an exponential sequence. So here we have an example of an exponential sequence which start with 11, 12.1, 13.31, and 14.641 and to beyond. So how to work out the nth term of this sequence? So first we're gonna find b. As you have remembered, the formula of an exponential sequence is ab to the power of x. So we could find b by dividing the next number to the previous number. So the previous number is 11. We're gonna take the next number, which is 12.1 divided to 11, which gives us 1.1. And as you divide it with the other numbers, it would give you the same results. So the nth term now could be written in the form of a times 1.1 to the power of n, where a is a number. So how to find a? As you could see, the first term is 11. So to find a, we would take a equals to 11 divided by 1.1, which gives us 10. So the nth term of this sequence is 10 times 1.1 to the power